Alright, let's start today. Start by typing this, training typing. I won't be talking much today. Save energy. Okay. Let me change the name of the stream. I think today is day 17. Yeah. I think it's right now. Returns an array of all objects that have matching. Name and value part of the source object has to be present in the object from the collection. It is to be included in the return array. Probably won't pass, but yeah. Yeah, that doesn't make sense also. What's wrong here? Shouldn't source be looking through the array already? Maybe not. do a look on an object inside of an array. That's the problem I'm having here. What's wrong with this? I think I know. There we go. the question is how do I specify the value inside the object? I was not pushing the one that I want. Nice, I think that's it. How do I specify by index? which argument of the object that I want.
So we're going to look at the array filter method. Similar to the array map method, the array map method in the previous video we talked about how we could take an array and call a function once for each of the elements in the array. The array filter does a similar thing. It creates a brand new array from another array by running through, looking at each one of the items in the array. It's going to call a function once for each of those items in the array, but this time the function is only going to return true or false. Instead of creating some brand new element to store in the array, it's just going to return true or false. If the function returns true, then the current element from the array that the function is looking at will be passed on into the new array. If it returns false, that element won't be passed in. So as an example, we've got here a variable called numbers. It is an array containing these 8 numbers. And I've got a breakpoint. I just picked a number arbitrarily saying 30. Say node array. There we go.
Now I can use like this. If you learn game development, it's fun and easier. Yeah, but that's not what I want to do in the future. What do you want to do? Maybe start a company or find a job related to AI or other things. AI is in video games, and games is where jobs are at. I'm a solo dev and I have to build AI all the time for characters in my games. Yeah, the thing is, I want to solve different types of problems. Like problems that have to do with the economy and more practical problems, let's say. Space travel, this type of stuff. Entertainment's not something that I feel like doing. Like engineering problems, let's say. And also AI self-destruction scares me a lot. So I wanna see if I can try to build something to try to prevent that. Maybe in the future. Although it seems almost impossible, but gotta try, right? Thank you. So the thing I don't know what to do here is how to specify the last value of these objects. Because they change every time. So I can't access by the specific name as I did on the first time I tried. Because if I do source.last, it's gonna be right for this one, but not right for the other ones. And the other ones also have more than one value, one key for both objects. So maybe I can use this. should be working. And if I do triple equals sign. Why is this giving me false if it includes the object?
Okay, hi guys. So today I'm just going to show how to write a simple compare matrix function that will take two matrices and return true if they're the same and false if they're different. And a matrix in our problem will be defined as an array of arrays. So basically an array of any level of nested arrays. The reason that we can't just use the equals operator to compare is because in JavaScript, arrays are objects, and objects cannot be compared using the equals operator. Unless, of course, they are actually the same exact object. So to demonstrate, in the console, I can let A equals to an empty array, and then I can let B equals to A, and now A and B are pointing to the same object in memory. So if I check A equals B, that is going to return true. But if I let a third variable C equals to the same thing, an empty array, even though the contents of both A and B are exactly the same, if I check A equals C, then it's going to return false. That's because they're pointing to different objects in memory. They're not the exact same object. So if we want to find out if two objects have the same contents, we can write our own function. So here I'm calling our function compare matrix, and we can go ahead and define our IOCE first, our input, output, constraints, and edge cases. Okay, so for our input, I'm going to say two matrices, and that's going to be basically an array of arrays, nested, any level deep. And then for our output, it's going to be true or false, so Boolean value. And then constraints, basically optimize, and then edge cases, empty array, or just array of arrays, nested, several levels deep. Great. Okay, so for this function, I'm going to write it recursively. Recursive functions do take up more space due to the space required on the call stack. However, for readability, I will write it recursively. So our function takes two arguments, A and B, both matrices, and those are the two matrices to compare. And for our base case, I'm going to return true if A is equal to B and false otherwise. But we should only be comparing if they are not arrays, or if either is an array. So I can say if a array dot is array, so if A is not an array, or B is not an array, so basically either is not an array, then I'll be comparing, so we'll return A equals B. So this will return false if either one is an array and the other one isn't, or if the values are not equal, and then it will return true if they're equal. So great. Otherwise, they're both arrays, and we can start looping through our array and comparing at each indice. So we can start writing our for loop for let I is equal to 0, and we want to loop until I is still less than the max length between A and B. So math.max of A.length over B.length. That way, if one stops short, it will still be caught by our base case and return false. And I plus plus. Okay, so inside our for loop, we want to compare each item at each respective indice to make sure that they are the same. So essentially, we are comparing if A at I is going to be the same as B at I. However, we're not sure if these items are arrays, so we can't just use the trip equal operator. We can, however, use our own function, so we can pass A of I and B of I into our own function. So we'll call compare matrix, and we'll call it with A at I and B at I. And since compare matrix will return true or false, we just need to store this result. So above the for loop, I will create a variable, let out equals to true, and it'll be true until we find a mismatch. And then I'll let the result here be stored into out. So if we do find a mismatch, it will store it as false into out. However, if out is false, to prevent it from being overwritten with true, if, say, in the next iteration, the next two items do match, we should have a check right here. So we can check if out is true, then we'll still go ahead and store it into out. Otherwise, return false. Great. So now we just need to return out at the end. So basically, either we found a mismatch and hit this return statement and we return false out of the function, or we keep getting matches and we keep comparing them and storing them into out. Now, if it's the final two items to compare in the array, it could be a mismatch and then store false into out. Then we exit the for loop and we return out, which could still possibly be false. So that's why we wouldn't just return true here instead of out. Okay, great. So now we can test our test cases. You can see that I've created a ton of test cases here. Okay, so let's go ahead and run that. And you can see that everything does pass. So now we'll go ahead and look at time and space complexity. So for time complexity, if we define n to be all the items in our matrix, however deep it may be nested, then since we're only looking at each item at most once, then our time complexity will be O of n, which we could say is still linear. For space complexity, since each time we call our function recursively, it places another call on the call stack, which takes up space, then the max space we would need would be the depth of the array. So basically however many levels deep our arrays are nested. And since the max depth would be n, then we can also say that our space complexity is O of n, which would make this also linear. Okay, great. And that's it for the solution. So if you guys have any questions, corrections, suggestions, or a better solution that you guys want to share, please let me know. And thanks for watching. Bye!
Okay, hi guys. So I'm going to code out this function called deep equals, and it's basically going to take two values, and it's going to return true if they are equal and false if they are not. And these values can be either primitive values, like strings or numbers, or they can be objects. And so first, you can see I've written out a few sample data, and down here a few tests. So I'm going to firstly do deep equals order matters. So, and I'm going to code this out in JavaScript with ES6. So let's see, it's going to take two objects, and order matters. Basically, what I'm going to do is you can see where let order one, order one, and order two. So if the order doesn't matter, then those two should be equal. But if order matters, then the order of the properties is going to matter. So that means order one and order two in this case would not be equal. So to do that, what we could do is stringify each one of the objects coming in. So JSON.stringify, and then you can just use the triple equal sign to compare them. And this should essentially give us what we want.
Problem here is that it needs to contain but not be exactly the same. So because not equal.
And we can test that out. So I'm going to comment this out, and then I'm going to run my code. So you can see it gives us true, false, true, false, true, false, false, true. Yes, and this order 1, order 2, you can see this should be false. Okay, so now we're going to write out the next deep equals, and that's the one that's where order is not going to matter. And so in this case, order 1 and order 2 should be actually true. They should actually be equal when we're done. So first, what we're going to do is, if they're primitive values, we're going to compare using the triple equal sign. So if A is equal to B, then we're just going to return true. Else if they are objects, then we need to check, right? So we'll check with the type of operator. If type of A is equal to object, and type of B is equal to object, then we will do additional checks inside. But otherwise, then we're going to return false. So now, what we also want to know is if these two objects have the same number of keys or properties. If they don't, then we also want it to return false, because then they're not equal. So we're going to do object.keys a.length should be equal to object.keys b.length. And this also works on arrays, because in an array, its index is its key. But as you can see, we have this null here. That's going to complicate things, because we want to make sure that if one is null and the other is not, then we go here, and null is an object in JavaScript. We don't want it to evaluate the key try to grab the key null, because that's going to throw an error. So we have to make a check to make sure it's not null. So we have to say if A and B exist, so they're not null, then we can go ahead and do the rest. And if any of that does not pass it, then it's going to fall through to false. Okay, so now they're both objects. We want to know that these two objects are the same type, that they are either both arrays or they're both not. So I'm going to say if array.isArray of object A is equal to array.isArray of B, then we will proceed to go through. But if they're not, then again, it's going to fall through to false. Okay, so now we're going to loop through these for key in A. So we're going to loop through object A, and we're going to say, for each property array, we're going to see if it's inside B as well. So if key is in B, then we're going to do something, but if it's not, then we are going to return false. But if it is, then now we're going to check the values are the same. And the way we're going to do this is we're going to recurse with our function, because our values may be objects as well, and then in which case we cannot compare with the triple equal sign. So, we're going to call deep equals, and we're going to pass in our value from A and our value from B. But the thing here is, now it's going to return either true or false, and if we don't do something here, it's going to return to nothingness. So we need to take this, whatever it gets back to us, and we're going to use it to our advantage. Now, if it comes back as false, then we want to immediately return false. So if this comes back to us as false, and we can just write it like that, because if it's false, it's going to not it, and it's going to be true, and then it'll go into this if block, and we will return false. But now if we've looped through every single thing, and it has not gone into this if block, it means that these two are in fact equal, in which case, right after our for, which ends here, we want to return true. And save. Okay. Let's see. So let me double check the code. So these two objects come through. If they are primitive values, we can compare with the triple equals. It's going to return true if it goes in here. If not, and they are both not null, and they are both of type object, and they both have the same number of keys, then we can go in and see if they're both of the same type. If they're both arrays or they're both just regular objects. And if they are, it's going to go through. It's going to go in here. If not, it's going to go here and return false. So then we go and loop through each one of these keys inside object A, and for each key in object A, we're going to check if it's also in B. If it is, if it isn't, we're going to return false. But if it is, then we're going to recurse with our function and pass in that value associated with that key for each object respectively, and check if it returns as false. If it does, then it's going to go in here and return false. If not, and we finish looping through our object, then it's going to go here and return true. So let's go ahead and run this, and we can see that it works. So let's just double check the values. It's true, false, true, false, true, false, true, true. And that is correct, because you can see here, the second function returns true, whereas the first one returns false, because the order does not matter in our second function, whereas it does in the first one. And you can see it's here, and there we go. So for the time and space complexity, if you want to calculate that, it's pretty easy in this case. So let me write it down. So time, complexity, space, complexity. Okay, so the time and space complexity for the first function is going to be basically constant, because all we do is stringify it. So it will be 1 plus the time. So we don't use any space here to store anything, so it's going to be none. Correct me if I'm wrong. So this is what I think is correct. Well, actually, I'm not sure about JSON.stringify what that may not be constant time. So this, yeah, this might be wrong. For the second one, let's see. This basically goes through the object and it goes through each part of it. So I'm going to say this is linear time. Oops. Linear. And again, space, we don't really store any variables, so it's going to be none. Yep. Okay. So that's it. Thank you.
Noite sem vazamento? Dia de festa. Máxima absorção a noite inteira.
Hello, it's me, I'm Tiny. I'm up here in my code. Oh, it's over here. This is the array. Oh, it's a nice array. I'm going to be here talking about reduce. So I reduced myself to a very small person, but I am going to unreduce myself back to my normal size to talk about reduce. That was totally worth doing. Wasting the first 30 seconds of this video for that bit of shit. Okay, so reduce. This is a really interesting and kind of weird and quirky higher order functions for arrays. And what's generally, the reason why it's called reduce is, let's say I have an array. And I want to take this array and I want to find out the essence of the array as a whole. I want to reduce it into one thing. So that's what this does. Now there's lots of reasons why you might want to do this, but I think probably the simplest scenario to start with is, I have an array and I want to add up all the numbers in it. I want to average all the numbers in it. So let's look at how that works with reduce. Right? First, let's actually do that without reduce, just to kind of like get the hang of things. So if I wasn't using reduce, I would say for let I equal 0, I is less than vals.length, I plus plus, and I would have a variable like let sum equal 0, and I would say sum plus equal vals index I, and then I would say console.log sum, and I would refresh up here, and we can see, there we go, all those numbers add up to 21. Now, if you've been paying attention to my ES6 videos, of which this is in a playlist, I could also say for let val of vals. So this is kind of like a for each style loop. There's actually something called for each in JavaScript, a little bit different. Also a higher order function that you can pass. Anyway, but this is like every val inside of vals, and oh, of course now I don't have that index, I would just do this, add them all together. So this is reducing it a little bit, reducing the code a little bit, and if I hit refresh, I've also got 21. All right, so let's look at how this reduce function works. And actually, before I write the code, let me come down here, and let me go and look at the documentation. So I'm gonna look at reduce. So reduce is a function that takes two arguments. And there's a way of doing it with one argument, which I will get to at some point, an accumulator and a current value. What does that mean? Accumulator and a current value. Accumulator and a current value. So this is not, reduce takes a function, it's a higher order function. So let's write a function that has both an accumulator and a value. So I'm gonna get rid of this code, and I'm gonna say function, and I'm gonna use ACC for short for accumulator and val for value. And I'm gonna say return accumulator plus value. Okay, return accumulator plus value. I think this is right. Oh, and let me name this. I'm gonna call this sum. Now I'm gonna say vals.reduce sum. And I'm gonna say let result answer equal that, and I'm going to say console.log answer. I realize I kind of just typed this down. I haven't really explained it yet. To be honest, I'm not entirely sure what I'm doing just yet. But hopefully this is going to make sense. It's going to work, and I can back up and explain it. Let's see. I got the answer 21. Okay. So what does this do? Well, do you remember when let me go back to my old code. I'm going to just quickly copy this. I'm going to go back to here. What if I actually called this ACC short for accumulator, and then said ACC plus equal val? Well, the accumulator starts with 0, and then every val is added to it over and over again. This is the idea of reduce. You give it something that's going to persist over time as it's looping through every element of the array, and then you can act on that thing that's persisting and the actual value of the array. Now, in this case, to add them both together, all I want to do, to add a sum, I just want this accumulator to always persist and just keep having each val added to it. Now, what's the weird thing about this is, what's the value of accumulator? Like, what does it start with? Well, interestingly enough, let's see if we can determine. I'm going to add console.log accumulator in here. And I'm probably going to need a bit more room in my console, so I'm going to do that. Look at that, 5, 9, 10, 12, 21. Interestingly enough, the first time I ran the code, the accumulator's value was 5. This is because I did not provide an initial value for the accumulator. So if you do not provide an initial value for the accumulator, it will, by default, be the first thing in the array, which is 5. Notice now, if in here I say reduce sum, and then I pass a second argument. So sum is this function, that's what I'm passing reduce, but there's an optional second argument, which is referred to as the initial value. So if I want the initial value of accumulator to be 0, I didn't have to do it for this problem that I'm solving, but I could do that here. Now I'm going to hit refresh. And let's look at what it did. Notice that it started at 0, so I have an extra console log. It didn't actually bother to run it with the first value, because it just started accumulator as the value, but the previous time, but now it's doing that. So just to make it clear, if I say 10, right, if I start accumulator at 10, you take this out, think about pause and think about what am I going to see in the console. Refresh. 31, right? Because I added all the numbers starting with 10. Okay. How can I condense this now? Well, first of all, I can use the arrow syntax. I can get rid of the word function. I don't need it to be named. And it's one line of code, so I don't need the curly brackets, and I don't need the return. So this actually can now go right here. And this is now, I'm going to give myself a little more space. This is the full line of code. I can say, hey, take this array and reduce it with an accumulator of a starting value of 10, and for each value, add that value to the accumulator. Okay, so in this case, though, if I really just want to calculate the sum, which I can call this sum, I don't want to start with 10. So I'm going to do this. And just to be aware, just to say it again, this is very important, especially once you start having like arrays of objects and other things. The accumulator, if you don't give an initial value, is not starting with like a default value of 0. It's actually starting with whatever the first element of the array is. So if you ever see this code, and I'm going to do this soon enough in a future video, where this is an array of particles, I might want to do something to say, calculate the average, the centroid of all those particles. I'm going to have to be clever about how I think about doing this. Okay, now, the chat gave me a good suggestion, which would be to find the maximum, or the minimum. And of course there is, I think, in P5 I know has a min and max function, it's probably a native JavaScript one as well, but let's try to do that. Let's try to find the minimum and maximum using reduce. So I'm going to write it out the long-winded way because it helps me. I'm going to say find max. And actually, this is great because this relates to some of my neural network videos that I've been making, where I'm going to have an accumulator and a value. Okay. Now, if value is greater than accumulator should equal value, right? Accumulator doesn't have to just be a thing that you're adding up together. You're saying it's just a variable that's going to persist while I'm going over the whole array. And value is each one. So if that current value is greater than whatever the accumulator is, then I'm going to get, then accumulator should equal that value. And then, I guess, do I need to return the accumulator? Or does that, by definition, no, yes, I need to return the accumulator, I think. So let's see. Let's take a look at this. So let's say let biggest equal vals.reduce find max. All right, so and then let's console.log biggest. 9. That's the now. Let's put 9 in the middle because just to be sure that it's really working because it was the last element. 9. It still worked. So I definitely need to. And if I take out this return accumulator, yeah, I don't get it. So of course I need to return that, right? Because the whole point is I'm going to return at the end. This is kind of you sort of get into it being assumed that value that persisted over the whole time. Now, how can I reduce this? So first of all, I can make this, as we know, an arrow function. So let's actually do this, and I'm going to put this here now into here. So this works. This is a little bit awkward looking, but this is definitely kind of functional style. I'm going to reduce, I have an accumulator and a value. I'm using arrow syntax and running this code. Let's make sure this still works. I get 9. Now, I could probably do :b. So all right, I'm back for another higher order function with JavaScript arrays video. And in this video, I will talk about filter. Filters actually, to be honest, it might be my favorite one of these. It's lovely. So let's look at so filter. The word filter means, it's called filter for a reason. Just like you might filter your water and filter out all the stuff you don't want. If you have an array that has some grime and stuff in it, you can filter it out. So how do you do that? It's a higher order function. So what that means is it expects as an argument some function. And what that function is a function that receives as an argument itself an element of the array. And based on that element, it should return true or false. And I always forget this. I think it returns true if you want to keep it and false if you don't want to keep it. So even though it's filter, you think true, I want to filter it out. I think it's true, I want to keep it. We'll have to try and look up the documentation. Okay, and I'm going to do the same thing. So this is where we last left off with this reduce stuff. We're still here after that. Thank you. And so what I'm going to do is I'm going to keep the same little silly array, and I'm going to write a function, and I'm going to say it is, interesting. Let's call this function is even. So what this function is going to do is it's going to take a number, and it will return true if it's an even number or false if it's an odd number. So it's going to if num, and how do I do this? I can use the modulus operator. The modulus operator, see the coding train video from Go 11 about modulus? It's an operator that gives you the remainder of division. So if you divide something by 2 and get a remainder of 0, it's an even number. So if num modulus 2 equals 0, then I want to return true. Otherwise, I want to return false. Now, I always do this because this is the kind of person I am. I will write it in 7 lines of code to make it say exactly what it's doing, even if it can be done in 1 line of code. But this is the moment where I think it's worth, today, these videos are a little bit about reducing the amount of typing. It's worth saying that I don't need to say if this is true, return true. If it's true, just return the fact that it's true. So this evaluates true or false. I'm going to just return that. So I can do this. Now I should be able to say, whoops, I should be able to say vals.reduce is even. I'm going to hit refresh, and there we only have the even ones left. So we have the even ones left because, based on the whether x modulus 2 equals 0. So this should give me exactly the same result. Again, this is the thing. This is why I hesitate. This is so unlike me. I would write this in like 10, but there's a wonder and beauty to this. Objects, and a few of them were undefined, were empty. I could filter out. This is going to give me, yeah. Right? So this worked as well. There is a live chat going on. Let me check if there's any questions. I think I'm going to need parentheses. Yeah, I'm going to need parentheses or words. So you can see, it was a dark and stormy night. Now, things could happen like, what if I had 2 spaces here by accident? And I hit refresh. Look at that. Because I had 2 spaces, I got an empty string by accident. Now, the truth of the matter is, if you watch my videos about regular expressions, I can be more 0 through 9, and that has to do with meta characters and regular. So I can use S here. I just was using S. I hope this was helpful to you about filter.
Novo.
Called has own property. Now, it'd be a good recommendation to check out the previous video because we talked about how to check an object for a particular property, such as name, and now we're going to be talking about a method that's going to do something very similar but a little bit different. Now, before we get started, please check out our sponsor. Are you looking for a JavaScript web development bootcamp? What about an iOS with housing at no additional cost? Learn how to user experience or quality assurance, and we'll give you $250 off the tuition. Link in the description. So here's what we're going to do. We're going to get rid of the second half here, and we're going to say teacher.hasOwnProperty. And inside the parentheses, we're going to put the property we're looking for, in this case, name. Doing a refresh, we still get true here. Expanding the object, you can see the name property is right there. Now, the difference here is hasOwnProperty will only check directly on the object and will not check the prototype. So scrolling up, you can see, for example, we have this active inside the prototype, but inside a teacher, we do not have that active property. So if we put active in here, when we do a refresh, we get false. But if we do it the way we had it in the previous video, such as this not equal to undefined, teacher.active, do a refresh, we still get true. So this one will check the prototype, and so will the other way, which look like this. And these strings are a little bit out of date, but oh well, we'll just get rid of name. There we go. So all we do is put active inside of quotes and then say in teacher, do a refresh, and you can see both of the old ways return true, but hasOwnProperty returns false. So that's how the hasOwnProperty method works. Hopefully that was helpful, and be sure to check out the next video because we're going to be talking about lots of cool stuff, specifically how to list the properties of an object. Thank you for watching, and be sure to subscribe.
So let's learn how to create an object inside of an object. You might think that sounds a little scary, but isn't that what we see every day in our real life world? We have a body object, we have a hard object inside of the body object. The hard object is made up of other objects. We have a car object. That car object has an engine object inside of the car object. So all these things where we have objects and objects, we see them all the time. We have a classroom. The classroom object is made up of student objects. We have a computer object. The computer object is made up of internal parts inside the computer, whether it's RAM, CPU, hard drive. Objects and objects is nothing to be afraid of. It's just standard object-oriented lifestyle that we deal with every day. So go ahead and create a brand new file. I called mine object in object.html. And I want you to take a moment and go ahead and type in all of this code. So pause the recording, type that in, then we'll just briefly explain it because you've seen all of this in previous videos, and then we'll start working with our classes. So let's take a look at what we're doing here. First of all, in the body, we have a button. This button has a label of display students. And if you click on that button, you're going to go to the display students function. We then have a field set to make a nice little box. And remember in an earlier video, we saw that this will make the box try to shrink down to the size of all the inputs. We have a legend for the text of that field set. So we see that on the box. We have a label for first name and an input to get the first name, a label for last name, an input for last, a label for GPA, and an input for GPA, and then a button that says add student, and when you click on it, you're going to call the add student function. Then we have another field set with a label on it of course info, and a label that says course num, and an input for course num, a label for course grade, an input for course grade, and a button that says add course, and if you click on it, you go to the add course function. And then the last thing we have in our HTML is a p tag with the ID of output. So let's start writing some classes to work with information. I want to create a class that represents a student. The attributes are going to be first name, last name, and that's common between students. We'll also have a GPA. However, I first want to start with a base class, a more general class, something that's common between everything. So I'm going to come down here, and in the body, I'll go ahead and start a script tag. And in this script tag, I want to make a class called person. And you saw this in previous videos. We'll have two attributes. We'll have the first name, and we'll have the last name. That's all we're going to do for that class. We're not going to write a constructor. We're not going to write any methods. We're just going to have a class with attributes. Then we're going to write another class called student, and that is going to extend or inherit from person. And we're going to add GPA. So this now says if I create a student object, I'll get GPA as an attribute plus anything from person, which is first name and last name. We're going to write another class. This will be called course grades. And we'll have a course num someday. It's going to have a GPA, first name, last name, and another attribute called grades, which is going to be a course grades object, meaning it will have course num and letter grade. So what does that actually mean? That means if I had a student called Buck Wheat and a GPA of 3.5, and then they had a course object, they would have a course num of whatever it is, we'll say 100, and they'll have a letter grade of an A. And I'll put both of these in quotes just because that's what we're going to be storing. And so this would actually create an object for the student, put Buck in the first name, Wheat in the last name, 3.5 into the GPA, and then it would put this inside the grade object, which would have a course num attribute and a letter grade attribute. Meaning, if I ever wanted to access that, let's say I had an object called OStudent, one of the attributes would be grades, and then the attribute for that would be course num. If you wanted to get the letter grade, it would be OStudent.grade.lettergrade. So it's the attribute in the object, which is an attribute in the object. So how do we actually write code to do that? In fact, before I continue, let me say that one more time. Letter grade would be an attribute in the grades object, but grades would be an attribute in the student object. And so you'd say object.object.attribute. So how could we actually write the source code to make this work?
Well, let's go ahead and start with our add student function. And I'm just going to paste some code and then explain it to you. That way you don't have to hear me hard typing. So here's a function for add student. Now remember, up here, we said if you ever click on this button, go to the add student function. Here it is. This isn't a method. It's not inside the classes. Right? If I minimize these classes, we'll see that that function is not in the class. Not in the class. So we said add student. We want to work with some variable and make this a global variable that we can use everywhere. So let's come up here and in our script tag, let's create a variable called oStudent equals new student. This now creates a brand new student object when the web page is loaded. Since it's a student object, it'll be based upon the person class. So it'll get first name and last name. It adds GPA, and it says I need a grades attribute, which will be a brand new course grades object, which will give you access to course num and letter grade. So let's go ahead and continue on with this function. We now said oStudent is equal to the new student object. Now in this case, we didn't really have to do that, just declare your variable. We didn't create an object yet. So we created a variable, and down here we said, in that variable, we'll make a brand new student object. Now that object is alive. We could have done it up top. You could also do it in the function. Since it's an object, you can say oStudent.attribute first name is equal to, go get the value from the first input, or the input that has an ID of first, which is right here. So that's going to be the first name input. And then it says, go get the value from the input of the ID last, sort to the last name attribute. Go get the GPA from that input, sort to GPA. And then what I did is I said document.getElementById course num.focus. This now will drop focus down to the other field set to this input. So it's waiting for you to do a course num now. Let's go ahead and add our function to do the courses. And I'll just paste that in, then we'll discuss it. So here's our add course. Remember, that's called when you click on the add course button. We said, go to the student object, access the grades attribute, and create a brand new grades object. Meaning, did I really have to do that here? Nope, it was already live. Well, let's go ahead and just say we're going to have an attribute and we're going to let the system create the course grades. However, will an end user know that? They might not. So maybe we just go ahead and leave this the way it is. And down here, we know that the oStudent already has a grades object created for it. Since the grades object is created for it, you can access the course number and the letter grade. And I just pulled those values out of your text box. So now we have a grades object inside of a student object. The course num is an attribute of the grades object. Grades is an attribute of the student object. So this is really an attribute in an object within an object. If I wanted to print that out to the screen, I could just go and write my other function called display students. Now remember, display students is called if you ever click on this button right here. And so in display students, I'm going to create a variable called soutput, and I'm going to say go to the student object that was created and grab the last name and concatenate it with the first name, concatenate it with a break. Then let's append to our output variable, so we're keeping like a running total almost. Append to it the student object that has a grades object that has a course num attribute, and concatenate that with the student object that has a grades object that has a letter grade attribute. Add some breaks to it, and then we assign that to the inner HTML of our output p tag. And remember, that was right here. Sorry about the ringing. So if I go ahead and run this now, let's see what happens. So I come to here, and first name, we'll type in Buck, last name, Wheat, GPA 3.5, add student, course number, 100, course grade, A. And before I do this, Control-Shift-I want you to see what's happening in the object itself. Here's my add course method. I'm going to click on add course. Here's my student object. It has Buck and Wheat, and one of the attributes is grade. Notice that grades is a grade object, a course grades object, and it has nothing in that attribute and that attribute. So now I'm saying, go assign to the attribute for the grades object for the student object. Step through that. Let's take a look. Buckwheat, here's our grades object associated with buckwheat. It now has a course number of 100. And now it has 100 and A. So this is a student object, has a grades object, which is course grades. The attribute name is grades, the object is course grades. The course num is an attribute in that grades attribute, which is a course grades object, inside of the student object. And let's go ahead and run that. And then let's come down to the display function. I set a breakpoint there. I'll get rid of the other ones. Click on display students. Here's our student object. Go get last name. Student object, go get first name. Student object, access the grades attribute, which is a course grades object. Get the course number. Student attribute, grades attribute, which is a course grades object. Access the letter grades attribute, which is an A. So by the time we're done, this should print out our information in our p tag. And there it is, buckwheat, 100 was A. And so how you can work with these objects is amazing, because now you can put objects within objects. And they all just have their own attributes, and they're all linked together. And all you have to do is just make sure that you set up your class correctly to where the attribute is an object inside of an object.
Nova Pampers Super Sec. Sem vazamentos para maior segurança. Dias seguros, dias Pampers.
In today's tutorial, we're going to look at how we can find out if two objects have the same data. This is a JavaScript problem that you may need to tackle once in a while. Welcome to another tutorial from All Things JavaScript, where we help bridge the gap between novice and expert. To be notified about new tutorials, make sure to click that bell button and subscribe. Also, check out the discount links to all my courses that I've included in the description of this tutorial. And if you're interested in supporting this channel, I have a link in the description for becoming a patron of the channel. As you may or may not know, checking to see if two objects are the same is not as simple as checking to see if they are equal to one another. Even if the objects have the same data, they are not equal to one another unless they reference the exact same object. Let's take a look at that really quick before we look at the solution. Now here I have two objects declared, obj1, obj2, and you can see they have the exact same data in them. Now, if I do a console log statement here and just check to see if they're equal to one another, like that, this is going to return false. Let's just go ahead and take a look at that. And there we have false. And the reason it returns false is because they aren't referencing the same object. Now, if we do something like this, obj3 equals obj1, basically what that does is make these two variables reference the same object. It doesn't copy the object to this variable. They just reference the same object now. So at this point, we could do obj1 equal obj3, and that will come back true. Like that. Now, what if we wanted to find out if these two objects, obj1 and obj2, had the same data? We didn't want to find out if they reference the same object. We just want to see if they have the same data. Now, the function we're going to look at is going to test to see if they have exactly the same data, but it could be adjusted to check to see if it has some of the same data. That's possible as well. But we want to look at a function that is going to see if the two objects have the same data or not. So let's set up that function. I'm going to call it has same data obj. And I want to set this function up so that we can pass objects in and then check those objects and find out if they have the same data or not. And this function will return a true or a false. A true if they have the same data, a false if they don't. So that's what we want to accomplish in this function. Now, the first thing I want to do is I'm going to set up a variable, just one variable, that contains the keys of one of these objects. We're going to compare the keys of both objects. I'm only going to use a variable for one of them because I need to repeat that. I'm going to be using that later in the function. So basically the steps we're going to take is we're going to check the keys of the objects and see if they are the same length. So first, make sure they have the same number of keys in them. That's the first check we're going to do. Then if it passes that check, we are then going to use the every function of arrays. And the reason we're using the every function of arrays is because when we gather the object keys from an object, it creates an array of those keys. So we're going to use the every function to see if every item in the object is the same as or has a corresponding item in the other object. So that's what we're going to do. So let's get into that. So first I want to gather the keys for object.1. And the way we get the keys of an object is using a static function of object, uppercase O. So object.keys, this static function will return the keys to whatever object is passed in and returns them as an array. So now obj1 keys is an array of the keys for obj1. So it'll have name, age, eyes. That's what it'll have in it. Now we want to do a check. We're just going to do an if statement here, and we're going to check if obj1 keys, and the length of that, is equal to the keys array for obj2. And I didn't create a variable for this because I wasn't planning to reuse it. I only had to use it once. So in this case, I'll just do object.keys obj2 like that. And so basically we're comparing the length of two arrays. Once I put the length property here, we're comparing the length of those two arrays to see if they have the same number of keys. So that's the first check that we do. If it passes that check, well, then we'll do an additional check. If it doesn't pass that check, then we'll simply return false. If they pass this check, we'll do another check. And if it passes that check, then we'll return true. Otherwise, false will be returned. So that's how we're handling this function. All right, now what we want to do at this point is we want to use the every method of arrays. So what we're going to do is we're going to take these keys and we're going to iterate through those keys and we're going to check every single one of them and see if object2 has the same property and that it's its own property and that those are equal to each other. Now, if you're not familiar with the every method of arrays, I do have a tutorial where I talk a lot about ES5 methods, one of them being every. But basically what every is it allows you to iterate through the elements of an array. You pass in a callback function, and that callback function needs to be a predicate, meaning it needs to return either true or false. So basically what you're doing is you're checking to see if whatever is passed in is equal to or not equal to, anyway, whether it returns true or false based upon some condition that you use in that function. And then with every, if every single one of the elements that gets passed in pass that condition and return true, then the function itself, the every method itself, will return true. Now it has a sister method as well, sum, which will return true if only some, at least one, matches that criteria. So every and sum, they're usually talked about together. So we are going to obj1 keys dot every. We're going to go through all of those keys, and what are we going to do with it? Well, we need to pass in a callback function that's going to indicate what we are going to do with it. So I will use an arrow function here. And if arrow functions are new, you can see some tutorials on that. I'll link to them in the description. So here's our arrow function, and here's what we want to do. We want to check obj2, and then we want to use hasOwnProperty. So one thing we're getting with this tutorial is we're getting some methods of objects that maybe haven't been talked about before. But hasOwnProperty, this method right here. What does this check? This checks to see if the object has the key that we passed in. See, here is the variable that accepts each key as we iterate through them. This variable will accept it. So we use that variable to check to see if object2 has that as a property, and that the property is on the object itself. It's not on a prototype. That's what hasOwnProperty checks. It has to be on the object itself and not on a prototype. So we want to check that first. And then we also want to do another check. So we're going to do and obj2, and then we use square brackets to access the value for that key. And we want to see if that value is equal to obj1, the same key. Now, remember, this function here will return a true or false. It has to match both conditions. Is the key a part of that object? And does the value of that key equal the value of the same key in the other object? If so, it returns true. Then it iterates to the next key in the array and checks that. And then the next key. And we'll keep doing that unless false is returned. If false is returned, then every knows that it needs to return false right away and does so. Otherwise, if every single thing passes the condition, it returns true. And so when it returns true, we want to return that true from the function itself, so that we then get an indication that, yeah, those objects are the same. Otherwise, if none of that happens, we return false. So the first check is the length, making sure they have the same number of keys, and then we dive into those keys, we look at every single one of them, see if they belong on the object, and then see if the values are equal to one another. All right, so there is our function. Now let's go ahead and try this again. Let's see if these two objects are equal to one another. So we're going to call has same data obj, and we're going to pass in obj1, obj2. Let's see what we get. Just going to refresh that. There we go, we get a true. So that tells us it's true. If we add something else to this, one up here, then what do we get? We get a false. So that's working for us. That's checking to see if those are the same. Now, one thing I need to mention before we're done here. This is a shallow check, meaning that if these objects have sub-objects, for example, if an array is included or if another object is included, it will not consider them equal to one another, even if the data is exactly the same. Let me show you an example of that. So if I do scores here, and that happens to be an array, like that, and I copy this exact same thing and put it down here, and now check these, we're still getting false. And the reason that happens is the same thing we talked about in the beginning of this tutorial. Basically, an array is an object. And so even though they have the same data, they're not referencing the exact same object, and therefore it doesn't pass. And so if we needed to do more than a shallow check, a shallow meaning there's not sub-objects, such as another object or an array, something like that, if we need to do more than that, then we'd have to modify this function so that if the value is an object, we then check that deeper. That's a lot more complex, but that could be done. But if we need to do a shallow check, this function works great for us in determining if two objects have the same data. Now, if you wanted to check to see if an object just has some data, at least one key and value that is the same, you could replace this with the method sum, and that would work. We talked about sum a little bit. And there's some other variations you could do with this, but hopefully that shows you what's possible in checking to see.
same problem from the first one. First time I did it. If I do this if statement, but then it's gonna give me the problem, the other problem. Yeah.
if objects have similar data. All right, I hope this was helpful. If so, please hit the like button, and remember to subscribe if you haven't yet. Also, I provide discount links to all my courses in the description section. And if you'd like to become a patron of this channel, I would appreciate the support. For a certain level of support, you can get access to the code files I use in every tutorial. And you can also contribute by visiting my website. I have a link for both in the description of this tutorial. Click the bell button to be notified about new releases. I release a new tutorial each week, and thanks for watching.
When you wish upon a star.
Da onde gente gosta mais.
Hey guys, how you going? My name is Dom, and in today's video, we're going to be taking a look at looping over objects within JavaScript. Okay, so over the years, there have been many different techniques when it comes to looping over objects, but in today's video, we're going to be taking a look at some of the more modern techniques. So that involves utilizing the keys, values, and entries methods, which are available to call with your objects. Okay, so let's go inside the text editor right here and begin by firstly just creating an object to loop over. So let's make a new constant right here called user equal to a new object, and of course the user is going to have a few properties. So we can say, for example, name as being Dom. Let's say age at 32, and occupation, let's make Dom a web developer. Okay, so now let's first take a look at the object.keys method. Okay, so the keys method is going to take in your object, and it's going to give you an array of each one of your properties. Okay, so right here we can say console.log, then pass through here object.keys, and then pass through here your user. Okay, so now saving this and refreshing, we can see in the console we get right here an array of each one of the properties on the user. Okay, so now if you want to loop over your objects and of course retrieve your value, you can do so using this method. So it's going to be really straightforward. Let's go back inside the text editor, and we're going to replace this right here with a for loop. So we're going to say for, then we're going to say const key of, then use object.keys once again, also passing through your user like we did earlier. Okay, so now it's going to loop through each one of our keys or our properties. Okay, then we can simply just say something like console.log, then pass through here using the backticks or template strings. We can simply say firstly the key, then we can do is equal to, then the value. So for the value, it's going to be really easy. We simply just reference the object itself, so in this case the user. Then we use these square brackets right here to pass through the key. So basically we can pass through key right there, and of course this one is going to give us the value. Okay, so now saving this and then refreshing the browser, we can see inside the console we get right here name Dom age 32 occupation web developer. So of course it's got our key, so each key and then each value. Okay, so that is your first technique for looping over objects. Okay, so the second one here, or the second method to cover, is going to be the values method. So this one right here works in a very similar way to the keys, but this one is going to give you your values instead. So let's go back inside the text editor, and we're going to be, instead of looping through, we're going to simply console.log, then pass through here object.values, okay, then pass through once again your user. So this one, like I said earlier, if we save this and refresh, it's going to give us an array of each one of the values, and we get Dom 32 and web developer. So unfortunately, this one right here, you're not able to retrieve your key and your value. This one is only for your values themselves. So there's going to be most likely less use cases for this, but of course I'm sure there's something out there that would of course make use of this. But I don't use this as much as I use these keys and entries. Okay, so moving on to the entries method. This one is sort of like a combination of the two which we just discussed. Okay, so and it's also probably the way to go when it comes to looping over objects. So let's go inside the text editor once again, and we're going to just say right here console.log and replace this one with entries. Okay, just like this. So now saving this and refreshing, we can see in the console we get an array of arrays. So we get a two-dimensional array, and essentially it just contains each one of our key and our values. Okay, so we can see here we get a total of 3 array elements in the first array. Then of course these ones contain your key and your value in index 0 and index 1 respectively. Okay, so with that being said, it's going to be super easy to loop over them. Okay, so let's go back inside the text editor, and we're going to be doing once again a for loop. So we're going to say for const, and this one we can just say, for example, entry of object.entries, then pass through here the user once again, and here we're going to simply just say console.log, the same example as we did previously. We're going to pass through here the entry at index 0. So of course, like we saw just then, index 0 contains your key and index 1 contains your value. So we can say entry index 0, then we can do right here, we can just do entries at index 1. So now saving this and refreshing, we get the exact same result. No, we don't. Let's try again. Okay, so this needs to be entry. Okay, let's try again, refresh, and we get this right here. We get, of course, the key and the value. So this one, it's a lot cleaner, or at least slightly cleaner when it comes to accessing your values. This time you actually have the value accessible inside the constant directly. But there's actually a cleaner way to go about this. So we're going to be using array destructuring to achieve a lot simpler, or and a lot simpler method. Okay, so right here we're going to pass through 2 square brackets. We're going to say right here key and then value. So this right here is going to essentially take the array of entry, and then it's just going to simply assign the first index to be key and the second index to be value. So now we can simply just do key right here, then we can just do value just like this. Okay, so now saving this and refreshing, we get right here the exact same result, and this technique right here is probably the way to go when it comes to looping over your objects. Okay, so that is how to loop over objects in JavaScript. Thanks for watching, guys, and I'll see you later.
Available for iterating over an object. As opposed to general objects, arrays have so many options available for working with the elements. In this tutorial, we're going to look at accessing the keys and values of an object through an array. Welcome to another tutorial from All Things JavaScript. As always, make sure to click that bell button and subscribe, and remember to check out the discount links to all my courses in the description. I really appreciate the support. And if you would like, there are other ways to support the channel, which you can find in the description. Now, the for in loop works great for iterating over an object, and we will look at that first. But sometimes you need a bit more flexibility, and that flexibility is offered through arrays. So we will look at 3 object static methods for converting properties to arrays. These static methods are object.keys, object.values, and object.entries. So here's an object. If you watched many of my videos, you probably realize that I do a lot of work with online courses. A lot of my examples represent students or testing or something like that, because that's what I work with most of the time. Well, this object is no different. But the data has not been consistently entered, especially when we're looking at the scores there. Now, with the for in loop, we can see all the properties and the corresponding values. And you can see how we set that up. We declare a variable inside the parentheses, and that will become the key of the key value pairs inside of whatever object we're looping over, in this case, student 1. And then we can log out the key this way. We can then log out the value by using square brackets to access that value inside of the object. And so if we just look at the console and see what shows up there, we get the key, and then we get the value, key value, and so on, all the way down to the end. So that works great. But sometimes it may be easier to accomplish something with an array of values. And we can convert the keys, or we can convert the values, or we can convert both of those to an array using these object static methods. Let me just show you them really quick, and then I'll do a really quick example. So let's say I wanted to get the keys as an array. I do object.keys, this is the static method, and then I pass in the object that I want to get those from. And you can see it returns an array, and each element is a key from the key value pairs. Now the values, we grab the same way, but we use the value static method. And there's all of our values. Now, if you want both of them together, you can get an array of arrays. Let me show you that really quick. That is object.entries. Now, notice it's an array. If we open that up, each subarray has first the key, then the value. We can see how that's set up there. So that may be a way you want to work with the object as well. Now, as I mentioned, arrays are much more flexible. There's a lot more ways to work with arrays than there are with general objects. And so by converting something to an array, or converting the properties to an array, it might make it easier to solve a particular problem, or more straightforward. Let me just show one example. Let's say I wanted to create a getScores function, and it's just going to grab all the scores from here. Anything that's a number, basically what we're going to do. And so we're going to pass in an object, so I can make this work for any object that's passed in. So I have a number of these objects to go through, and I need to pull out the scores. So what we want this function to do is return scores. And so we'll return the results of object.values. So there we get an array of the values of whatever object is passed in. So now we have an array. But if we want that array to only include scores, I need to check and make sure things are a number. That's one bit of information I know about this object, that all the scores will be a number. Even if they're entered as a string, they can be coerced to a number, so they are like a number. But I don't want to get any booleans. Booleans can also be coerced to a number. For example, let me show you that really quick. If I come down here and I do number, and then pass in a boolean value, that's converted to a 1. A false would be converted to a 0. So those would be considered numbers as well, using the technique I'm going to for this particular function. So just wanted to point that out. So I have arrays here, so now I can use any of the methods that are available for arrays to work with that. And there are a number of those methods that are available. I'm going to use filter in this case. Now a filter is something you're not familiar with. I'll include a link to a tutorial on that, on some of those different array methods. But what filter allows me to do is take an array and filter out those values I do not want, and it returns an array. And so basically what I get back is an array with only the values I want. And I just want values that are numbers, or that can be numbers. So that's what I'm going to do with filter. Now the way filter works is you need to pass in a callback function. And that callback function adds a variable val. Now I'll just is be returned from this function. So this is going to get placed into the new array if true is returned from this function. And right now true will be returned for everything that's a number, because I use logical not to reverse the is and. However, that will also be returned for this boolean. So I'm going to eliminate that. And type of val not equal to bool. But I just wanted to illustrate that if we didn't have this part here. All right, so a simple example.
I'm gonna do this for a little bit to clear my mind.
In this tutorial, we are going to look at a couple of additions that came with ECMAScript 2017 that help us work with the data in objects. If you need a refresher on objects, I've included links to object tutorials that I've created in the past. In fact, I've included a link to an object playlist that has several tutorials on objects. And I've included that in the description section of this tutorial. Now, when it comes to working with data, arrays make that process much simpler. In fact, there are several methods for arrays that make it much easier to work with data. And you should explore these if you haven't done so in the past. And I'll include a link to a playlist for arrays as well in the description section. Now, since arrays are much simpler to work with, what if we could convert the key value pairs in objects to arrays? Well, that is possible with the static methods that are now available on object. Let's take a look at them, and then we will look at some examples. So there are 3 static methods available on object. The first one is keys. So we access it by entering object.keys, and then we pass in the object we want to work on. And what that returns is an array of all of the keys of the key value pairs that are part of that object. The second one is .values. And what that returns is an array of all of the values. And as you can see, it functions the same way. Object.values, and then you pass in the object that you want to act on. And then finally, if we need both the keys and the values together in an array, we can do that using object.entries. Pass in the object, and it returns an array of arrays. So each element in that array is an array that consists of the key and the value. Now, keys has been around for some time, but values and entries were added with ECMAScript 2017. And with all 3 of these together, it makes it working with data and objects simpler. So let's look at some examples. Now, here I have an object. And the purpose of this object is just keep track of students and the score they receive. And we're using the email address of those students to keep track of that. Now, what if I wanted to then begin working with this data? How would I do that with an object? Well, let's look at how we would do that with an object first, and then let's look at what these methods can do for us. So first off, let's say I want to sum these scores. I want to get a total for all of them. So I will set up a sum variable, and then we can use a for in loop to loop through all of those key value pairs within the object. This will allow us to loop through those. Then as we loop through them, we will update the sum variable, like this. This will allow us to access the value, because right now the val variable is set to the key for each of those key value pairs. And so this will allow us to access that value and add it to sum. So that's how we could get the sum. Let's go ahead and take a look at that. We jump out. Let me refresh, open the console, and then if we enter sum, there we go, we got the total. Now that's great, that's not too difficult. But now let's say, well, I also want to get an average. Well, that adds to it, so I need to do more. So I need to keep track of a count, how many there are, so that I can compute an average. And it'll create a variable to store the average in as well. So each time through the loop, I need to increment count. And then once we're done with the loop, then I can figure out the average, something like this. And that works for getting the average as well. So now that works fine, but as we continue to want to do more things, it just gets more complex. So let's see what these new methods do for us. I'm going to comment this out. And what I want to do is I want to create an array of values so that I can just work with those values. So I'm going to call that scores. And I'll set that equal to object.values. This is the static method we're using, and I need to pass in the object that I'm going to act on, so students. Let's go ahead and take a look at that as it is. So now if I display scores, you can see that we have an array of all of the scores that were obtained from that object. Now that makes it very easy to work with, and much more flexible because we can do multiple things with this array. So let's say we wanted to get the sum. We could do something like this. We could use the reduce method of arrays. Now, once again, if you're unfamiliar with the reduce method, refer to that array playlist. There is a tutorial in there that talks about these array methods. Now, normally setting this up, I would use arrow functions, but I haven't done a tutorial on that yet, and so I'll use a regular function. But what this reduce function is going to do is reduce the array down to a single value. And we're going to tell it to do that by adding the values together in this way. And then I want to pass in an initial value. So that will give us the sum. So now we have the sum. Well, I don't know if that was much easier than what we did up here, right? It's a single line, but as far as ease, I don't think that simplifies things much. But now let's say we want to get an average. We can now do that simply like this. We don't have to add anything to our previous code. We just do another line of code to get the average. Let me refresh that.
Can we just go
And there's our
look for
average.
the answer?
Now that's not all. Let's say we also wanted to get
making any
an
progress
array of
here.
those scores that we're passing, and right now we're considering 80 as passing. Well, we continue to work with our scores array, which we set up. So we can set up a passing array, and we can get
about
all the
everything.
scores that are passing using the filter method of arrays. Once again, I have to pass in a function. This is a higher order function. Reduce and filter are both higher order functions, and so they take a function as a parameter, and then it uses that function to determine what is returned. And once again, if these are completely unfamiliar with you, please refer to those previous tutorials. And what we're going to do is return all of those that have a value of 80. And so the way this is working, filter cycles through each element of the array, and it passes in each element into this variable. And so we simply check to see if that value is greater than 80. I have to go back to past code and modify it to get something else. So I like that. That's, in my opinion, easy. Entries allows us to. We're added with ECMAScript 2017. Keys have been around for a while, but values and entries are new to ECMAScript 2017. So make sure that you're targeting browsers that support those if you plan to use them.
Hi guys, I'm Adam, and I'm sure many of you have heard about Lodash. It seems like from day one at Full Stack Academy, it's something that was talked about all the time, and yet it's this mysterious tool that none of us really feel prepared to use yet. So I want to talk to you about how you can bring it into your code and clean up your code and how it can help you. So what is Lodash, why do you need it, and how should you use it? Lodash is a utility module that defines a set of methods that can perform common and often reused functions. People who are not coders like to think that coders have like this superpower of making programs, and if we were a superhero, I feel like we're most like Batman, because like our real superpower is just that you're smart and prepared and hardworking. But Batman only goes as far as his utility belt can get him, so you need the best tools at your disposal. An example of utility function that Lodash would provide is counter case. The code above is what you would write if you were going to write your own counter case function. It's one that everyone here is capable of doing, but when you look at it first time, if it wasn't called camelize, you probably wouldn't know at first glance the purpose of this function. So this can help you clean it up. You can bring in this one camel case function. It handles all of your test cases, your dashes, white space, all of the side cases that you need to be aware of. Another utility function that's really helpful is max by. We all know map.max can be called on arrays to find the highest number, but if you use max by, you can bring objects and you can call iterator functions on what you're searching for and then measure the result of those iterator functions. Or if you are specifically just looking for one quality on every object, you can put in a string and it will test all of them. It iterates faster through objects than actually native JavaScript does, so there are a lot of benefits of just bringing it in for things like this. In JavaScript, everything is an object, and dealing with JavaScript objects can be kind of a hassle. They don't have classes. They take up a lot of memory. It takes a long time to work through them. So Lodash can help you work with all the JavaScript objects. Specifically, copying objects is something that takes a lot of time and a lot of memory. So here we have Batman. He's a superhero, and his has powers is false. So if you want to make a copy of that, you'd say the flash is equal to Batman, and then set the flash as powers equal true. But lo and behold, because JavaScript is passed by reference, you've actually also set Batman's powers to true, which we know that's not true. He just has a utility belt. So using the clone function, you can create an exact copy of it and then edit it without ruining your original data. Thus, truth and justice can prevail. Another way of copying objects, I find this one actually much more useful for most cases, is using assign or extend. And the example here, foo is created with a property as is bar, and then we also have properties on their prototypes. And assign will copy over every quality from, you have the initial object, and then it'll copy over every quality for objects following that onto the first object. And it will overwrite qualities, but the object will still maintain any other qualities it has that are not mentioned. And then extend is a kind of a more deep version of that, you can remember extend is more deep because it ends in a D, that actually goes to the object's prototype and copies all of that qualities over to this object as well. In JavaScript, all arrays are also objects, and sometimes they are hard to manage. So an example of creating an array, you can use Lodash's times function with unique, and you'll create an array that has a label with different numbers for every item. Also, looping through arrays can be kind of confusing sometimes.
So because they're stored as an object, arrays have an index that starts at 0, 1, 2, 3. And those are the keys to get the values that are stored in the array. But you could just set a random polygon array starting with an array of 100 is equal to 100, or an array of a string A can give you another value. And luckily in Lodash, we have two ways to loop through these. That gives you exactly what you're looking for. So you can either loop through it for each, which for each, when called on an object that has a length, will loop through it array-wise, meaning it will start at 0 and go until the length, and run the function on each thing. If there is nothing there, it actually will stop running the function and won't return things that you don't want. But for in is often a better case if you have extraneous information, because it will go exactly to each value. It'll run object.keys and then loop through that array. Also, working with functions. Mixin is a really good function to learn how to use. It brings in methods onto an object or brings in methods onto a function. And it's a really good way to, if you're using Lodash, to customize your Lodash that you're using to have functions and utilities that you need. So in this case, vowels filters out a string to only have the vowels. And what they've done is they've called mixin on an object using vowels, placing vowels. And now Lodash, in this case, will have that function as Lodash.vowels. So you can save all utilities that you want to add in that are specific to your case onto this utility function to use throughout your app. So it may seem like a lot of these things are things that you could do on your own and they seem very simple, so why should you use Lodash? And one thing is that it should make all your code more declarative and also optimizes runtime. So declarative code is code that should say what you're doing and not how you're doing it. A good example of this is in loops when you use times. If you are going to a specific number, if it's not a varying number that you're going to loop through, then you can just say times and the number of times you're going to do it and run the function. And this actually runs faster than the for loop does in V8. And it also helps you have function scoping rather than block scoping, because in for loop it's block scoping and you need to use let or const block scope. Whereas this will create a function so you won't have any scoping issues. And also the way V8 runs is if you have block scoping, it's currently only running ES5. So it's going to run it as if it's function scoped, but it does a check each time you use that variable, reassign that variable to make sure you are allowed to. So if you use the times function and now it's function scoped, you don't have to run that check anymore as a function scope. Another way that you can keep really declarative code is with the chain method. Chain is a function given by Lodash that lets you add lots of Lodash functions in a row, and it will provide the result of one function into the next. So rather than having to read across this entire code, and even though it's in ES6 and easier to read, it's still a lot to read across to figure out the order in which it's happening. Whereas knowing that you're going to map it, then flatten it, then sort, and return the value is a much easier way to read this. Lodash is also optimized for speed. It's a lot faster than a lot of native JavaScript functions, which a lot of people think the native JavaScript has got to be the fastest way because any add-on is just going to use that native JavaScript. But it's actually not the case because...
Hello friends, welcome back. Today we're doing another intermediate algorithm scripting project called Wherefore Art Thou. So we want to make a function that looks through an array of objects, the first argument, and returns an array of all objects that have matching name and value pairs, second argument. Each name and value pair of the source object has to be present in the object from the collection if it is to be included in the returned array. For example, if the first argument is an array with the first object of Romeo, last Montague, and then the second object is Mercutio, and the last name is Null, and that the third object is Tybalt, it's first Tybalt, last Capulet, and the second argument is Capulet, then you must return the third object from the array. The first argument of the array, and the array is the first argument because it contains the name and its value that was passed on as a second argument. Remember, research asks if you get stuck. Write your own code. Okay, so this one seems a bit tricky. Well, the first thing that we want to do is iterate through our collection, right? Because we want to be able to grab each individual object and then run a series of tests to see if they have the last key and the last value of Capulet. So we're going to start with collection. This should be collections. So we're going to go collections dot for each, and then we're going to say collection. Okay, and so if we console.log our collection now, this is the collection we're working with, right? Okay, so we've got Romeo, last is Montague, and so we've got three objects. We're iterating through the objects. Let's see, what does that compare with our source? Our source is this one, last Capulet. Okay, so our collection, source, let's see, the source last is Capulet, so object dot value of source, object dot key, keys of source is equal to last. Okay. So maybe we could iterate through our keys. Yeah, we could iterate through the keys of here. And the way to do that with objects is we could go object, we can say for let key in source, and then we could console.log key. Okay, cool. So now we've got our key, and this will work for if we have more than one as well. So if we have last and then first, and we call that Juliet, we would get last first. Here, I'm gonna comment this out for now. Last first, last first, last first. So now we're iterating through here. We've got our key, and we also have a collection. I'm gonna get rid of this. Okay, so now we've got a collection and we've got our key last first. And so if we were to, well, collection at last would be Montague, right? So if we go collection at key, Montague, Romeo, and then if we did source at key, Montague, Capulet, Romeo, Juliet. Null, Capulet, Mercutio, Juliet. Capulet, Capulet, Tybalt, Juliet. Okay, let's get rid of Juliet for now. This is not part of our test sequence. So yeah, none of these match. And so collection and source key, I mean, we could go if collection is equal to source key, then we push into the array, right? Because we have an open array. So array.push, and then we put our, what do we put? We want the collection? Yeah. Console.log, the collection. Nice. Yeah, oh, here's what's going on. Down here, we need to set this. So let's call this let the result equal here, and then we can just console.log the result. Cool, this is actually the right answer. I can get rid of this console log now. This is what we're looking for. This is the array first and last Capulet. So yeah, that matches. We can run the test. Okay, cool. We've got 2 of 6 tests passing. So let's pass this guy into our test and see how that goes. Okay, cool. So I can immediately see that we're duplicating it, right? Every time that this matches, this is, yeah, let's console log the collection. So, and then let's get rid of the answer for now. So apple 1, bat 2, bat 2, bat 2. Okay, so what's happening is each time that we iterate, we're writing these to the thing, collection. Is that right? Yeah. And so if we need to say, yeah, okay. Here's another way to think about it. Let's just console log the key in here. The key. Apple, bat, apple, bat, apple, bat. Apple, bat, apple, bat, apple, bat. Interesting. Okay, so and then the key, and then the source key, and the collection key. Apple 1, 1, bat 2, 2, apple 1 undefined, bat 2, 2, apple 1, 1, bat 2, 2. But in our result, what we're getting is this massive, we're writing it on more times than we need. So we need to have a way to we need a way to make sure that all of the keys have been iterated through before we give it the option to iterate here. So we could do it with an index. I think we could go let index equals 0, and then we could say, yeah, we could go index plus equals 1, And then if we console.log the index, then we'd have a 1, 2, 1, 2, 1, 2, 1, 2. Let's get rid of this console log just to keep it clean. 1, 2, 1, 2, 1, 2. With each key, we're indexing up. So if, let's see here. Let's say the index, and then we want to say the collection key. What happens there? 1, 1, 2, 1. 1 undefined, 2, 2, 1, 1, 2, 2. So what's happening here? We're going apple bat, and then the index is equal to 2, apple bat, so that would match. This one would not match, but then this one would match, and that's what we want with this one right here. We want to get 2, but we don't want this one. So I think what we could do is say, if the collection key, then we iterate up. What do we want to say? If the collection, oh, this is the index. If the collection key is equal to the, wait a second, collection key. What about source key? Undefined 1. If the collection key is equal to the source key, then we add to the index. Oh, that's what we're doing here. And now we could say if the index is equal to the source, we need to know how long the source count is, right? Right here we've got 1, 2 values, so we need to find the objects in the source. Object.keys source. But object.keys of source will get us, so we need to go length. You see, because we're getting apple bat, apple bat, apple bat, so we need to go dot length, and that'll give us 2. So if the index is 2, then we're good to go. Let's see what happens here. Okay, it looks like, okay, this is working now. So what we're saying is, yeah, let's, the index and the collection and the source. Okay, so index is 0. Oh, let's put the key in there too. Let's put the key in at the beginning. Okay, so the key is apple. The collection key is equal to the source key, which means apple, 1 is, so the collection key is equal to apple, and that renders out, or the key is equal to apple, and the collection is here, and the source is here. So it says apple, it renders out, is 1 equal to 1? Yes. So then we add to the index, bat. Bat here is 2, and bat here is 2. So we add to the index. So, oh, we can console log the index down here. Okay, so 1, 2, and then so index, and then if we do, let's do, yeah, and then the object key's length. So I'm just printing these out together so we can see. So we iterate through the first time, the index becomes 1, but it's not equal to 2, so we skip this. And we're checking to see if apple. The apple is 1 here, and it's 1 here. So the second time, it's bat. Bat 2 here, bat 2 here. So we add to the index, here, and we come down, and we check here. The index and the key source is 2, because it's always, the key source is always 2, but the index is finally reached to there, and therefore we push into the array with the collection, which is apple 1, bat 2. The same thing here, but in the first one, apple is not part of here. So we got undefined. So because it's not there, the index is not incremented. And even though our next source key is bat, and bat is here, the index only gets to 1. The index only gets to 1, so it passes through here without pushing to the console, pushing to the array. And then we iterate, we come back through to our next collection, and the index is reset to 0. And so we do it again. 1, 1, 1, 2. Oh yeah, this is where we ended up. And then on our last one, even though we have 3 elements, it doesn't matter, because the source only has to go through 2 to check if it's the apple and the bat. Man, I bet this will pass. Okay, cool. Let's get rid of all these console logs and see if we can refactor this a bit. First off, array is not a good way to, and it's never a good idea to name your variables like array if they're an array. It's obvious that they're array. We should say the matching result, right? And then change that down here. So that way the code is more readable. Oh, here, let's see. Okay, so yeah, here I need to have matching result as well. Cool, I'm gonna get rid of this console log as well. And there's a lot of console logs this time. Get rid of this guy as well. Okay, cool. So now the only thing that we're logging to the console is the result, which we want. Man, how would you refactor this guy? I'm already using the for each in the collection with the arrow function, so I can't do much there. I don't really know how to reindex this index thing. There's probably a way to do this with a filter method, which involves some conditionals, some tricky conditionals. But you know what? I'm just not even gonna do it that way. I'm gonna call this one good. This is kind of a tricky one. You know, this is something that you might run into as a real software engineer. So I wouldn't say don't worry about it. I'm sure that there's other ways to do that, but this is going to be the way that I'm sticking with for this tutorial.
So I was saying I might run into this problem. He did a nested for loop. Outside declares a variable. Before that. Okay, in source. Well, so basically made a variable to count the thing. If index equals object keys, so if the key on the source, the length of the keys in the source is equal to the index, it pushes. So it makes a conditional statement to count for a variable. So if they are equal, index plus 1. Do the other way around. No, still not turn. What was the other way I was doing when I was working? I was pushing the values. So So why is this not working? Exactly what the guy did. I think he used filters, used a for each, and I'm using filter. That's the difference. If collection B. So if the keys are equal, the variable inside of the object is equal, it sums the index. Then he used this index to verify the length. But I don't understand why this works if source is bigger than, is smaller than the object is compared to. Because then the length of the object is going to be like 3, the length of the object is going to be 2, and the index is not going to match. So why does this work? I put slash b index here. Let's see if it passes exactly like he did it. For each stuff. So they probably changed something. I feel like I've tried everything I can think of. Maybe if I change from smaller. Maybe it's just a variable here. That's wrong. We should be returning instead of push. It doesn't change anything. Now it's returning. I think that was the problem before. Yeah, there we go. Nice. The reason why it wasn't working was because of the variable there. Because I made to push r equals push r. Doesn't make sense.
Thanks guys for watching, and we'll see you in the next one.
So this assumes a variable inside of the source. And if this variable inside of this variable, which is going to be each item of the collection, variable inside of the collection is equal to a variable inside of source. It increases the index, and then it uses this index as the if statement to see if it's gonna return or not. I don't understand how this index can be equal to the object's key length on source. Some of them is gonna be bigger. For example, this has 2 and this has 3. So the index should be 2 because 2 verify, but the length should be 3. So the length is 2 also. Is the length of source, not collection. Let me see something. This doesn't work. Returns are all of them. Because all of them contain apple. Oh, so it's only gonna count through for the index when it finds a match. Oh, and that excludes the ones that are smaller than. Okay. Or that doesn't contain light. No. I think I understand now. So what I did wrong was not assign a variable to keep track. That's the difference from what he did and I was trying to do. To keep track of the size of the ones that are correct. And we'll see the solution of this. Return false in the one with statement is correct. We use a if statement to check the object in the collection does not have the key and the property value doesn't match the value in the source. Check if the object in the collection does not have the key. So it makes a variable to keep track of the keys on source. Then returns for every returns object has one property key. Function key. So the variable for every is key. It's checking if it has one property key. And the other variable outside. No, this is confusing. And object key equals source key. In my example, the way that I did it would be name key equals source key instead of object, and name has one property key. I tried something similar, but it didn't work. I don't know why. And though I didn't do it like this, though. object key source, and then do the every number, please. I think I'll meditate in a few minutes and then read this again for more clear mind. Action source. Intercollection. So basically the same as the other solution. We use a map instead of every. And then reduce. Convert a string to spinal case. Spinal case is all lowercase words joined by dashes. Mas não converte to lowercase. A new string function. Okay. So I don't need this split. You can only use join for arrays, I think. Replace maybe. Why it doesn't convert? The same is going to. Maybe I just need to make equal. Oh. It's still wrong. This is definitely. So why is this wrong? Doesn't make any sense. It should be a regex here. I'm only catching the first letter, but that's not what I want. I want to break the string when it reaches the first letter. Yeah, that doesn't make sense. Because I'm telling you to speak the letter, not the word. Slice, maybe. Yeah. That's weird.
Hello friends, welcome back. Today we're going to do a spinal tap case, a project called spinal tap case. This is a lot of regular expression stuff. So we want to convert a string to spinal case. Spinal case is all lowercase words joined by dashes. So they spell that out as you see it there. The first thing we want to do is deal with converting camel case to snake case. So that means where this is camel case here, what we want to do is place a space in between here. And then once there's a space, it'll be easy to convert a space to a dash. So first thing we want to go is we'll create a new string and we'll call this one camel case handled. And then in order to handle the camel case, we're going to take the string and we're going to replace inside there, we're going to create a regular expression, and then we're going to have what we replace it with. And the regular expression is going to replace, we're going to have first we're going to create a group. We're going to create two groups. And inside the first one is where we see in the string a lowercase z, a lowercase letter from A to Z, and then an uppercase letter from A to Z. So this is just going to select all the situations in which, you've got a lowercase letter here and then an uppercase letter here. And then what we want to do is replace that. So we're going to use money1 and money2. This is going to be, and we want to do this globally so that it iterates through the entire string. And then we're going to want to return the camel case handled, and then I want to set this to result, and then console log the result. Okay, so right now nothing is happening. That means something's not right. Oh, okay. So right now this is the group 1, and then this is group 2. So I need to add a space in here. I'm going to pull this out just so it's a little bit easier to read. And so yeah, this is where. So I'm replacing the A through Z. We're grouping where we find a lowercase letter right next to an uppercase letter. And then we're setting that to the group. And then in this replace function, you can say money1 says the group and money2 says the second group. So we're able to select these and then we're able to adjust them. Let's say we wanted to put an exclamation point in between them. Then we would have an exclamation point in between each of these points. And so now we have our camel cased string spaced out this way. And then it's we can handle the dashes. And so we can say, now we can say spaces and dashes handled. And we can set that equal to the camel case handled, which is the string that we're working with now. And we can say dot replace. And then we want to create another regular expression that's globally. And then we want to replace these with a dash. And then for these, the space is 1. Now that we've got this one working, we can throw it into the return statement. And then we also want to handle, I think, an underscore. The underscore would be an example, the Andy Griffith Show, this one. Cool, and now we're handling that. And now all we have to do is make everything to lowercase. Cool, and now you can see it passes the test. So yeah, first off, I'm just going to throw these in here. We handle the camel case, and the dashes still aren't handled. So then we handle the spaces and dashes, and that's where we get this. And then we return that result. Yeah, if you run the test, it passed. Thank you guys for watching. We'll see you in the next video.
Space or dash or capital letter. Look up capital letter. I think I'll leave this show for tomorrow, for the other day. Kind of tired already. And I have to play poker later. Console cluster. Oh, understand now. So when it reaches the first vowel, you put it to the end and add A to it. So adding A should be the last step. There we go. But I don't wanna paste the word like this. You want to replace one add, that's the thing. Doesn't work. Where's the join? Not that. easier doing like this. So if it begins with a consonant, take the first consonant cluster, move it to the end of the word, and add H to it. So when it hits this point, I should move this string to the end. Yeah, that's the problem. Maybe a step break here. The C is being added. which is what I'm supposed to do, right? No, that's the problem. Yeah. I'll be right back. So the issue is I have to cut the string from the point that is stopped loop, and then I can add the string to the end. Yeah. Actually, I think I'll stop for today. I'm too tired to keep going. And yeah. Okay, I'll be back another day. Maybe tomorrow or after tomorrow. See you.